Hey everyone, and welcome back. In this episode we're going to run an automated performance test and check the report from CSV Profiler. The script for launching the performance test is at this path. Let's take a look at what is going on inside it. As you can see, it launches Unreal Automation tool, gathers the launch arguments and runs an XML file. Among the arguments, you will notice that target configuration is set to test. Like I mentioned before, that is the best choice for capturing metrics. Now let's look at the script that this one calls. Here we see some variable declarations, and at the very bottom a call to another script. That is the build and test project XML, and this one is huge. It can do a whole lot of different jobs. What matters for us right now is that it can build the project, package it, and run the test. Before we run the test, I want to show you one more file, automated Perf test command settings XML. Here you can see the other arguments available for this script. For example, this one lets you record the Unreal Inside trace, and we will use it later. And this one lets you record the video during the test. I very much recommend you to dig into the arguments and find that one that fit your task. Let's run the script. The process kicks off, and next it will compile the code, cook the content, and then run the test once that is done. By default, it runs all three sequences we saw in previous episode. The work is done, so let's find the report. In this folder you will find the raw CSV files with the recorded metrics, along with the report generated by the native Perf report tool. For more on working with Perf report tool and the different ways to generate reports, check out a great article by my colleague. You can find the link in description. Let's open the generated report. As you can see there is a lot of data here, all laid out in an easy-to-read format. You can check the load on the game thread, render thread, GPU separately and figure out where the bottleneck is. I will not go through the whole report in details, feel free to explore it yourself. Let's jump straight to the section where we can look at the game thread load in more detail. This chart lets us dig into the heaviest metrics for the game thread. You can see here were the huge spikes in these frames, and that is what caused the freezes. The heaviest scopes here are async loading, add to world, create all instance bodies, navigation build, and tick actors. Add to world and async loading, that is exactly that work that happens within the level streaming actors update time limit and async loading time limit budgets we looked at a previous episode. Navigation build is set up as fully dynamic in this project, and that is why navigation mesh update is very expensive. I'm just going to turn it off since it is adding noise, and getting the NAFA mesh update settings right is its own big topic, and it is outside the scope of this video. Create all instance bodies is something interesting, but I will not spoil it right now. We will cover that in the next episode. So there is pretty much everything we can pull from this report. It is not a huge amount of detail, but that is the point. This report is meant to give you a high-level view and let you quickly spot where there is performance problem at all. In our case, we can see that there is one. This report is also useful because it is built on the CSV profiler, which is very lightweight and barely adds any noise to the metrics. You can read the report right in your browser, and it is typically used for daily reports to keep an eye on your project's health and catch any regressions. Alright, we've done with this report. Now we need to gather the more detailed data. For that, we need to record an Unreal Inside trace. The script we ran earlier can do this too, but there is a problem. Every time we run local perf test file, we have to wait for the code to compile if it isn't already. Then we wait for content cooking and packaging, even if we already have a build ready to go. That takes a huge amount of time, especially on big projects like ours. Right now we just need to run the test on a build we've already got. So I made another script file that does exactly that. As you can see, we're still launching Unreal Automation tool, but this time we're telling it only run test. Here we point to the engine location, the U project file, the build, the test name, and a few other arguments, including that ones we used in the original file. I will drop a link to this file in the description so you can use it for your project. In real production, you will likely use separate agents for building the project and for running performance tests. For builds, you will want powerful machines that can compile code and package the project fast. For performance testing, you will want to use your actual target hardware. So this work really should be split across different scripts. Looks good, but before I run this, I want to set up a new test scenario. I checked out the 3 sequences that shipped with the project, and I wasn't too happy with them. The camera either moves around a small part of map, or it follows a path that doesn't have many objects to stream in. So I built my own scenario and added it to alongside the existing ones. It is a simple sequence with an animated camera, and you can easily set up something like this for your own project. Then in project settings, you just point to the sequence asset and give the test name. That is the name you will use in the script file to make sure this scenario is that one that runs. Since I added a new scenario, I need to package a new build to ship those changes. Okay, I have a fresh build. Now let's run the new script. The work is done. Let's find where the .utrace file got saved. You will need Unreal Insight to open it. I usually associate this file type with the program, so I can just double-click to open it later. And here is our trace. We will analyze it in the next episode. See you there!